Binomial expansion is something you need to know about for any advanced math you go into. You have to be able to expand things. Let me tell you what you're doing. If you had x plus y to the 5th power, is that x to the 5th plus y to the 5th? Not even close. It's not even close. Think of it this way. What's x plus y squared? Is that x squared plus y squared? No. What's in between? When you multiply x plus y times x plus y, what's in between? You get the x squared, you have the y squared, but what's in between? 2xy's, right? Now, notice that with this squared term and the Pascal's triangle, what are the coefficients of x squared plus 2xy plus y squared? What are the coefficients that you see? 1, 2, 1. We can get these coefficients right off of Pascal's triangle. And that's what I'm going to show you right here. So if we did a plus b to the 0, anything to the 0 is just equal to 1. I want to have something that shows here. That's good. A plus b to the 1st is 1 times a plus 1 times b. You see where the Pascal's triangle 1, 1 comes from? A plus b squared, we just said that's 1 times a squared plus 2ab plus 1 times b squared. How about a plus b cubed? Well, I know I'm going to have an a cubed. I'm going to have a b cubed. But I'm also going to have an a squared b and an ab squared, which we're going to talk about. What do you think these coefficients are going to be? Well, I know these are going to be 1s. But what do you think these are going to be? I'll give you a hint. We did this already. And we've done this. What do you think these two are going to be? What do you think? Nick, what do you think? 1 plus 2 is 3. Yep, 2 plus 1 is 3. These are going to be 3s. And this is the pattern we're going to use to expand any binomial. And I think it's pretty cool. 2, 1, 1, 1, and Pascal's triangle. So let's take a look at one like x plus y and go to the 5th power. This is not hard. You just have to pay close attention. We're going to think of x plus y to the 5th as x plus y times x plus y times x plus y 5 times. Ugh. Do you want to multiply that out 5 times? No, and we don't have to. We'll never have to. But if we did, you'd be multiplying all these x's first, giving you x to the 5th. Do you agree with that? Then the next thing we're going to have is we're going to have a y times all of these. So you're going to have x to the 4th, x to the 4th times y, and then you're going to have x to the 3rd times y squared. Then you're going to have x to the 2nd times y cubed. Then you're going to have x times y to the 4th and y to the 5th at the end. Now, I like, instead of kind of making it look like you're memorizing it, I like to do it this way. I call it descending x's. So we start, it's going to be x to the 5th at first. Then it's x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, x to the 0. I won't write x to the 0, but I could. Then it's y to the 0, y to the 1st, y to the 2nd, y to the third, y to the fourth, y to the fifth. These would be ascending y's. Maybe I will put those in. I'm going to put those in. What do you notice is the sum of the exponents every single time? What do you notice is the sum? It's 5, isn't it? Yeah. Okay, so I descended the x to the fifth, fourth, third, second, first, 0. Okay, then I ascended the y's. There's one more, excuse me, one more thing I need to do, and those are the coefficients. How am I going to find the coefficients that go in front of these? Well, I go back to my Pascal's triangle. I do have to go all the way to 5 because it is the fifth power. So it's 1, 5. What will the next one be? 10, 10, 5, 1. So my answer will be 1, 5, 10, 10, 5, and 1. X to the fifth. And if you want to clean all those up, you can. This will just be x to the fifth times 1 plus 5x to the fourth y plus 10x to the third y squared plus 10x squared y cubed plus 5xy to the fourth plus y to the fifth. That is the expansion of this. Ugh. Do you understand it, though? Does it make sense? Now we're going to do it with some trickier ones. We're going to do it one here, and then I think you'll be all set. 2c minus 4 over d cubed. So we're going to do 2c to the third, 2c to the second, 2c to the first, 2c to the 0. Then I'm going to go negative 4 over d to the 0, negative 4 over d to the first, 4 over d to the second, negative 4 over d to the third. I do the descending. This is my first part. If you want to call this A, and the second part you call B. You descend the A and you ascend the B. The powers always add up to 3. I forgot one thing. What did I forget? It's not done yet. What do I need yet? Need the coefficients. Pascal's triangle, 1, 1, 1, 2, 1, 1, 3. It's the powers 3, so I go to this 3. So this is just 1, 3, 3, and 1. Now the algebra here has to be finished. 2 cubed is 8. C cubed, 0, anything to the 0 is 1. 3 times 2 squared is 3 times 4 times negative 4. What is that? 3 times 4 is 12, times negative 4 is negative 48. C squared over D squared. This is negative squared is positive. 16 times 2 is 32. 32 times 3 is 96. C over D squared. And the last one is this to the 0 is 1. Negative 64 over D cubed. And this is the expansion of 2c minus 4d to the third. I take this first part, 2c, descend, take the negative 4 over db, ascend, and then put Pascal's triangle and multiply them out. Ta-da! We are ready for homework. Assignment day 1, go down, way down, to assignment day 1. And it's quite a ways down because there's a Pascal's triangle investigation we're going to look at tomorrow. These factorials we'll get to, but 10, 11, and 12, and 13 I want you to do for tomorrow. And I want you to try number 18. Do those expansions. There's 5 of them. And then just to kind of tell you what this is, Anytime you see a factorial, it's 3 times 2 times 1. So this one squared is just going to be 36. This one is 10 times 9 times 8 times 7 times 6 times 5, 4, 3, 2, 1 over 7 times 6 times 5 times 4, 3, 2, 1. You can see a bunch of stuff canceling, leaving 720. Okay, I'll assign these for tomorrow, but focus on numbers 10 through the end because those are the things that we're working on the most.